Yeah, go ahead, Sterling. Okay. Okay. Yeah. All right. I'm going to be using the data Collins gave to us. I don't know whether Collins, are you here? Collins, are you here? All right. Collins is not here. When you have this type of data like this, always make sure you have a heading, because in QGIS, what it will do is that it will pick the first one and take it as part of the headings. So it is necessary you try as much as you can to make sure you have the heading, so that you know the type of data you are selecting, and that's actually going to go a long way. So I'm going to save this. I just save this as Easton, Norton and Height. I wanted Collins to know whether he is here, to confirm if what I named Easton, Norton and elevation is actually true. So this is like a data collected from the feed, and these data are in Easton, Norton and Height. As you can see, this is it. So I'm going to save the data, and I'm going to ArcGIS. All right, so I am here. We are going to be talking about 3D aspects of using the point. You know, the last time we worked with 2D, but today we are going to be working with 3D. So I'm going to be using my mouse. All right. Okay, so I'm returning back to normal where the data is. The same thing we did last time. This is the data we're going to be working with, and I'm going, like I said, I'm going to go to File, go to Add Data, and go to Add XY Data, and I'm going to browse the location, and I'm going down to the connection folder. I'm going to download, and I am going to select the Collins and click Add Data. I have serial number, and I have Easton, I have Norton. Now Easton X, Norton Y, and remember the Z value this time. This is what you know. We are adding the Z value this time because we need it. Now I am going here, and I'm going to look for UTM zone 32. So I'm going to search, because that's where I think the data is located. That's why I'm asking for Collins, because Collins, to be sure if Collins gives us the right coordinate system. So I want to project it. So if you go to the projection coordinate system, because it's a matrix, you can see UTM. And if you go to UTM 1984, you go to Northern Hemisphere, you see UTM zone 32 here. This is where it is, and you click OK. Now when you click OK, you can see the coordinate system here. If you want to show details, you can click here to see more details, like the semi-major axis, the inverse, that's the flattening, the semi-minor axis, where is it, which datum is this based. You can use this to show more information about it. If not, you just look at it like that and pass. Once you finish, you click OK, and it will ask you that this data does not have object ID. All these things are questions, so you need to click OK, and it's going to come up like this. So from what Collins gave to us, this is a graded coordinate which he gave to us. So when you have this, I am going to here to go inside download, and then probably I am going to click on new and new folder. I'm going to write these things as Collins. Now when this is done, I want to save my data here, because I don't want it to get myself stressed up on looking for the location if I'm doing export. So I'm going to desktop, and I'm going to download, just to save my data in the folder named Collins. and I'm going to use these things. I'm going to type it as XYZ as the coordinates, and I'm saving it here where I save it as XYZ. Now this is an event file. Like I said last time, the same thing you did, click on data, click on export, and click here. Now for me now, I am going to click home because I have saved it in Collins, and I'm going to change this thing as I'm going to write it points. And I click here to save, click here, and once it comes up, I will click add, and I will remove the event file. This is what I need now. So this is the coordinates of the place Collins gave to us, and it is graded at a particular interval. So I want to change the point to probably another color that I want, and I'm going to click OK. Now this is the coordinate you have. You go to the field and you get elevation, and it is graded in XYZ, and this is perfect and okay. So if you work and your client asks you to show me the point features, this is how you are going to show it. Now you can decide to label this point, even though in the Excel here there was no label from what Collins gave to us, like what he labeled it in the instrument. There's no label. You just 1, 2, 3. Then if you're doing a hydrographic survey, you will get this type of points too. And then what do you need to do? You just need to label it, and in labeling you can see it labeled it by the numbers 1, 2, 3, 4, whatever it is. You go to the properties here and then change the label and label it with label tab. Change it from serial number to elevation, because that's what you want to label it with. You can bold it and you click OK, and that is going to change it to this view. You can see 32.18, 32.17. So by your own measurement, you can see what is happening here. Now another thing I want you to see is that open attribute information. As you see, click on it, right click on it, and go to statistic. Now when you go to statistic, you should be able to see the statistic aspect of the point. How many is the point? Is 168. Which point have the minimum? The minimum here is 31.6. The maximum is 33. That means the difference between each of these elevation is the difference between the elevation you have here is this. So you can see what we have here. This is the difference here. Now the next thing is the standard deviation, is that it is deviating by this, and the mean is 32. Now 0, there is no 0. Now I want to add another value here, which I'm going to do add field, and I want to see the difference. Now what I'm teaching you, I'm talking about now, is something you need to know. So I'm going to put it in double. I want to know the difference because I don't have time to calculate what is the difference. I want to know what is the difference between the highest point and the lowest, because if you go here, go to the statistic, you see I have 31.61 and I have 33.04. I want to crack my brain to check what's the difference between two of them. I can quickly check the difference between each of these value to what it is. So what I'm going to do is that I'm going to right click here, and I say down here, go to statistic. Now what is the highest point here? The highest point here is 33.0. You can see here 33.04. I can click the difference here and go to field calculator, click yes. And now what do I want to do? I want to do 33.04 here. This is what I want, minus the value of elevation. This is the calculation I want to make, and when I click OK, it is going to run and give me the changes, the values, the difference. So the highest range minus the lowest. What do I want to determine? In my mind, I want to know which point is the highest point and which point is the lowest point. To do that, I can right click here, go to statistic, and you see here the difference between the highest point to the lowest point here is 1.43 meters. So this is what is the highest, the minimum point, the highest, the difference between the minimum and the maximum point on this elevation. So the changes that take place here is, as you can see here, by right clicking here, go to some statistic, the maximum is 1.43. that automatically give me the difference between the lowest point and the highest point. So I just did a mathematical calculation. We will be doing more of this as we proceed, because like I said, I am going to show you what each of these tools here do, and then how are you going to work them, because I want you at the end of the day to be sure you can do any type of analysis in GIS, as no matter how tough it is, even the unimaginable things, as you go on, you will start seeing the unimaginable things that you need to do with GIS that you think it is not going to be possible to be done. Now, we're going to start with what? Geoprocessing tools, which is ArcToolbox. We're going to start with ArcToolbox, and then where here we can access the geoprocessing tools. Now, what I did was just like a mathematics to calculate and show you the difference, to label it and show you how you can label it. Because if it is hydro, you're going to label these things in this way. If it is elevation, you're also going to label it this way. And you see the way it is labeled one side. If you want to label it by another side, like by tilting to a particular triangle or an angle, you can make it like this. Go to placement here, click on placement. You see, if I change this, change location, if any one of them are selected, that is going to be applied to that way. You see the way change it, it comes down under it. Placement, go to place on top of the point, click apply, it will place it on top of the point. Go to placement again, place it at a particular angle. I want to place it at the angle of 45. I'll enter 45, I'll click add angle, I'll click OK, I'll click OK, and that is going to change the labeling into that particular angle. And then I can also place it at a particular field. I can rotate it to a serial number, rotate it to elevation, put it to geographic or arithmetic, place it perpendicular to the angle. You can do whichever way you want to label it, and that comes in to that particular way you want it. Then all these ones are more about the way you can label. So ideally, these are different ways you can make your labeling. As you see, it goes in that way. You select the text and do it the way you want to do it. But that's not what I'm interested. I just want to show you how it works. We are going straight to how you can build a contour with this. Now on this note, I'm opening up here. Now see this ArcToolbox. I am going straight to 3D analysis tools. Here I go to 3D, then here I'm going to data management. Here under data management, I'm going to team. Here under team, I'm going to create team. Now team is triangular irregular network. Now I'm going to show help, create a triangulated irregular network dataset. Now on this, where do I want to save my team? I want to save it in Collins, so I'm going to click home, and this is Collins. I'm going to save it here in Collins. So I'm going to create a new folder, and I'm going to label that folder as team, and then I'm going to select it, and I will save, type team inside it, and I will save it. Now if you go to the folder of Collins, you will see I have team inside it here. So now I'm going to come back to it and go to team, select it. What coordinate system? This is optional because these have already selected the coordinate system of the layer by default. So I'm going to leave it by default here, or I will change. That's why it is optional. Input the feature class. This is not optional, it's CAM, because you have to input the point you want to work on. Now the Z feature automatically read the Z part here as a Z feature because it understands it's a shape, and because you selected the Z feature when you're uploading, it picks up this and knows it's a Z feature. So if you leave it here, it works. If you also leave it here, it works. And you also believe that you can still use the difference that I have created to also create the same contour that same way, but just that the value will be different. So for sake of what we are doing, I am going to click on elevation. Now what type of way I want to create it? There's different method. Mass point. What field are you going to tag? I don't want to tag any field, so I'm going to leave this by empty. Then you can create other one. See, you can add different ones. So if I click here, I can also, this is how you select and you add. You click again, you can select another one if you have many points here. So but I don't need that, so I'm just going to send this one away. So once you are done, click OK. And depending on the speed of your system, you are going to get result positive or negative. So automatically the speed of my system is a little bit not healthy, so it delayed a bit, but at the end it comes out. Now it have created triangular irregular network. Now what do you mean by triangulated irregular network? If I turn off this and if you zoom very close, if you zoom close, you see that it forms a certain triangle. Look this line here to here. Look this line here to here. Look here. You see the way it forms this particular triangle. So this is what it does. See the way it forms the triangle. Now you see it makes this triangle in this way and join it wherever you need to join. So this is what you get here first. Now after getting this, for us to create contour, you need to go back to Arc toolbox and close up this, still in 3D surface where you are. Here you can see here I'm still within this region. Now you have different other distance like sorry, you have this you still have this aspect where you have your 3D. Now this is your 3D, and then you have a conversion tools here. You look at the conversion tools on this. I finish with data management thing, create thing. Now I am going to the same thing in 3D here, analysis tools, go to conversion. After conversion, go from raster, that is when you're converting from raster to thin. But now I want to convert from thin because it is triangulated irregular network that I have to convert from thin to raster. So I'm going to click on thin to raster, then select thin, and then where do I want to put it? I want to put it inside here. I can just write it elevation model and whatever I want. Linear, these are different method. When it is float, we already know what is float. We have talked about it in Python very well. So you should know what float means when it comes to this aspect of our data. Now let me just talk about it a bit. When you talk about float, it means that it's going to bring this data into dot, and it's going to come in 32-bit float point. But when you talk about it in integer, the R is going to be in integer approximate this thing, like it's going to be in integer. Now, Sterling, can you explain this thing to me based on the knowledge you have in Python? Sterling, are you with me? Or you have left us?
Yes.
So can you explain the difference between this output type for me? Can you just give me a simple example?
The output of float.
Float and integer as pertain to this thing we are talking about now.
Okay.
Have no idea?
I should, but I think I just know that float is supposed to come with the decimals, and then the integers is without the decimal. But applying it to here is what I cannot say now.
Can you call a friend?
A friend. Yeah. Okay. I can call thinking. She's yeah, Stephanie is here.
Call a friend.
Stephanie. Steph.
Oh, I'm here. Oh, I actually have no
Mm-hmm.
idea.
Stephanie, call a friend.
Ah, I'll call on Collins. W. Collins. Help us out.
So, your Collins, can you help
Okay.
us, please? Because me, I don't know it.
All right. With the knowledge of Python.
Okay.
Sorry, you called me initially. I was carried away. Sorry. So
Okay.
with the knowledge of Python, this float example of it will be 2.3 or 2.4.
Okay.
That is going to come out with the decimal point.
Okay.
That is, whatever you're going to be do here, the output of it will come out in decimals.
Okay.
Then the integer is going to round it up to a whole number. That is 1, 2, 3, 4, 5, and 35, 36, and just like that.
Okay.
That's the
Samuel
simple.
Collins, between
Yes.
the float and integer as pertain to the raster we want to create, like elevation model we want to create, which one is better?
The float would be better. I
All
think
right.
so.
Thank you so much. When we are done here, go and drink one bottle of beer. I will pay. I'll come there to pay. Once you see me, I'll give you the money. So that's that's what I want you to understand. When you talk about flutes, it breaks this thing into smaller particles. That's why when you are, let me give you example, when you are collecting an elevation data, if you use 10 meters intervals, you can't compare it with somebody who use 5 meters interval, because the person that goes 5 meters interval goes to a breaking point, like a detailed way. When we'll be talking about when we'll be talking about cloud point, you will understand the difference between the cloud point and just normal point you pick. And the cloud point is majorly used for a real-time deformation, like a very good precise monitoring. So what I want you to do, all of you to do, is that when we are done, or if you're with your handset right now, go to our general group, click on the profile picture, and zoom into that profile picture. You will understand the answer to all these things we are talking. That particular profile picture was created using a team, and it is in cloud point in centimeter. You can see that there is changes in elevation. What it created have, you see the way it is looking. But what Sylvia Collins gave to us is 10 meters interval. It's a bit coarse. So you will understand the difference. If you want to make a monitoring, you will see that our profile picture does that data. The profile picture we have about 983 point within a short place that is smaller than this place Collins is give to us now. So imagine such kind of point that you have even into centimeters. So float will be better, as he said. So the next thing is to click OK. Now linear natural neighborhood, you click on it, you calculate the sales by applying the linear interpolation to the thin triangles. Natural calculate the sales by neighborhood interpolation. I'm going to be talking about this by the time I leave here to give you also another example to explain this. Then Z value, you majorly use Z value when it is in degree. What you are using is in degree. We are going to talk about when we do slope calculation. I'm going to exercise on this. I'm going to give you why when you need to convert this. I'm going to leave it in 1 because we are matrix. So I'm going to click OK. And that is automatically going to convert this for me into this. Depending on the speed of my internet, my system, I should be able to see the difference. Now, let me a bit talk about the linear before I go ahead. Now, this is, if you look at this, you will see that I'm zooming very close for you to understand what I'm saying. Now I'm going to click on image analysis here, and I'm going to select this term as name as them. Look at this. The linear here, which is the nearest neighborhood, uses this. You see the grid. You can see this thing have a square. You see it is showing you a block. But when I change it from the nearest to by linear, that is the linear, you see it become, well, you see the way it change. Now it is using that is 4 neighborhood triangles to form this. Now if I change this into cubic convolution, it is using 16 bits, that is 16 size of this point. You will understand this when we talk about it a bit deeper, but what you see now is a perfect example of what I'm saying. You see this is showing you by pixels. I change it from this down to by linear interpolation. You see the way it get curved up, and then I change this down to full width. You see the way it change up. So don't worry about it. We'll be talking about this thing extensively. So I'm going to stop and let's proceed what we are doing. Now I am done with calculating, converting it to thin to raster, and I have to do this. So I am going next now to surface. I'll close up this and I'm going to surface down here, and the open surface. Spatial analysis tools, that's where I'm going. I'm going to surface, and when I go to surface, remember in our calculation I've seen that the difference is 1 meter. So that means if I make this in 1 meters, I might not have, if I put this in 1 meter, I might just have one line crossing here. I'm going to create a contour. I'm trying to explain to you why I'm using that particular, I check that intervals to know what I'm going to use. Now if I use, remember contour, I'm going to select contour. I'm going to save this in an default because I have not made my decision on the best thing to use. So I am going to make the contour interval at 20 cm. So I'm going to put 0.2 in meters and I'm going to run it. Now it's going to create a 0.2, which is 20 cm interval contour for me, and this is how it looks. Do you see the problem? The problem is that if I use 1 meters, imagine what will happen. I would do maybe one line will pass. For a quick sake of our talking, let me change this, select the them, and I'm going to use 1 meter. Now see, look at what is going to happen. I use 1 meter. Now I'm going to turn off the 20 cm. See what is going to show. Maybe it might even not even show line. And you see what I'm saying? Only one line here. So what are we going to do with one line and another one line here? If I'm not mistaken, this is the entire thing they want to give us. Doesn't make sense. So that is what you need to know. That's why I check those calculations to see what is the difference between what is the highest, what is the lowest, so that I'm able to know what am I looking for. Now look at the 10 cm. I'm going to remove it because look at the 20 cm. I'm not comfortable with it, because if you are giving this into architect for architectural drawing, it doesn't make any sense. So for me, I would prefer to go with 10 cm changes. So I'm going to click on contour and I'm going to select the them, and I'm going to go to here on the contour. I'm going to use 0.1, and when I use 0.1 here, I'm going to click OK, and I'm going to run this way, and I think this will be a better option. Now I'm going to remove this, and I have 10 cm, and you can see the way it goes in here. So you can see here 10 cm. Then the next thing I need to do is, in surveying, we call line smoothing. This thing is fighting with me. A contour supposed to be well smooth. You see here, it is not making sense. So that is why I have not exported the contour to where I want. So I'm going to make it a curve, because this contour is supposed to pass through here, and go like this. So I'm going back to Arc Toolbox. Remember where I'm going to? I'm going to surface, closing up surface. I'm going to close up this. I return back to normal the way it is. I'm going to cartography tools, and I'm going to down to generalization. I'm going to what we call smooth line. I'm going to smooth the line. The smooth line is smooth sharp angle in line and improve the aesthetic or cartographic quality. Look at this triangle here is not making sense. So I am going here. I'm going to select the contour them. Then I have not want to put it to here. I just want to put it up there. Now we have 3 ways, which you call peak, which is polynomial approximation with exponential kernel. It calculates a smooth line that are not passing through the input line vertices. This is default. This one is another way that fit the basal curve based on the vertices. The result line pass through the vertices. So I prefer using the peak. Now how many meters I want to trim it, within what meters, we're using what. So I will let me just say in horizontal, this is horizontal part. So I'm going to let me just use 5 meters. Check. This is when there is issue of error, when there is topology, because there's a way you're going to put this thing. One contour will come and jump on another contour. So you look here, I'm going to do a short measurement. If I take a measurement between here to here, I have about 207 centimeter. Let me change it to meters. Distance, change it to meter here, and I have about 2 meters. So there is a way you're going to make the curve, and if it is 5, the 5 meters is going to jump and jump on another line. So that is what I'm talking about in the other side. So now I am going back to here, and I'm going to say smoothing line, and I am going to open up this and click on this, go back here, select peak, and I'm going to put 5 for example, and I'm going to run it. I'll leave the rest default, and I'm going to click OK. Now I want to show the difference between them because we have few lines remaining. So this is the difference between them. Now the contour is not fighting with me again, as you can see, but the difference is that I have improved the quality using 5, and you see the way it curves. If I turn off this, you see this is how the contour is supposed to look. We are not fighting, so it doesn't have to look like we are fighting. See the difference? I curve it a bit. Now this is not what it's supposed to be. It's contour supposed to look nice, look beautiful, like Stephanie. So it's supposed to look beautiful that way, not looking hard like Bullock. We don't like people that look like Bullock. So it's supposed to curve this way. So you can look the difference between them. The issue with it is that if you input it much, you see that at about 8 cm, 0.8 meter, you are saying the wrong thing. So that is why it is necessary you know how many this thing you are going to put, so that it will still fall within that particular place. So for now, let me take this out and assume that this is okay. So automatically I have this type of curve contour, and I am going to click here, and the next thing is right click on it, and now I can now export this, and then I'm going to export this and make it, and I'm going to type it contour underscore 10 cm. So I'm going to save this because this is the one I accepted, and this is going to add, and I'm going to remove this contour, and this is okay. The next thing is I can label it. Now this is labeling by the number. I'll go to the properties, click on it, and I am going to like change this to contour, and properties, I'm going to label it on the line. Remove this, label it on the line, and then click OK, and that's going to label this on the line for me. And if I need to put it in, I'll go back there again. I'm going to change the size, probably put it in this, bolding it to 12, make it bold, and I can click OK, and that's keep it on top of the line for me. And this is how the contour is supposed to look for now. As you can see here, this is the way it is. So you have 2.2, 2.1, you see here, this pass here, this is almost the same thing with the way they pass. So this is how we are going to get a contour, and we have 5 minutes remaining, and in the 5 minutes, this is contour. Remember what I said last time, all these things we are going to do, we are going to do a project, all of us is going to cry together, because I want you to know how to produce a topographic map, and this topographic map will come with aesthetics, and we see who knows how to make things work the way it's supposed to work. But from what I'm saying now, you can see this here, you see the way the contour is and the labeling goes. Now the last thing I want to talk about before we finish in the next 4 minutes is this thing was, a point was gridded in 10 meters here. This is here, this is 5 meters, not 10 meters, 5 meters, and their boss tell you, I need this thing in 10 meters, what am I going to do? And that's exactly what I'm going to do now. You went to feed, you collected the data, or you collected it randomly, and they ask you, rebuild it to 10 meters, 5 meters, 2 meters, 1 meters, and that's what they need. This is what you're going to do. In 5 minutes, I'm going to do it a bit fast. I'm turning off this, I'm turning off this, I'm turning off this. and I'm going to Arc toolbox again. I'm closing up this. I'm going to data management tools. I'm going to sampling under data management tools. I'm going to click on create a fishnet. Now here I'm going to create the output and I'm going to type it fish 10 meters, and I'm clicking OK. Now output, I'm going to select the dem that I created. This is the output. You see automatically picks it. What size of the cell? My organ said I should make it 10. I make 10 here. What is the size of the height? I will also make it 10. And once I click this will check off. Now this is 10 by 10. I want to get it 10 meters, and I'm going to click OK. So I'll wait for it. Depending on the speed of your system or my system, is going to come out quick. Now you can see that this is 10 meters over the same location. Then if you turn on this, you see that it will be overlapping with it. You see here, this is 10 meters. This is what I want to get. It doesn't must coincide with this, but if you check the distance between all of them, you see that what you have here is 10 meters perfectly. This is it. You can see here. This is, you can see it here. So 10 meters is what you're having. Then I'm going to turn off this because I'm still working on this one. This one is a line that it's using creating it and giving the centroid. So I'm going to send this one to hell, remaining the point. That's what I need. Now the next thing I'm going to do is that there are two things I'm going to do, either by changing this. Let me change it so that you will see it better. I'm going to reduce this into 8 or 7 and click OK. Then this is the point I have here. If you turn on the elevation, you will see that this is where it is. To make it faster for me, I'm going to do select by location. I'm going to select the point that I have here. This is select by location. I'm going to select by location. Select by location. Then I'm going to select from the feature and only selectable layer. What is happening to these tools? In current layer, removable layer, select from the current layer, full. Select by location. What is happening? So my select by location is not showing any customization. 3D analysis. Statistical analysis. Okay, my village people are knocking at the door right now. Yeah, I don't know, should I let them in or should I let them go? Because as it stands now, I don't know why my select by location is not on and it is not adding any data into this layer at all. That's why I say they are knocking at the door. So maybe I will need to check the license on this. So but nevertheless, I'll go ahead and do what I want to do because I wanted only to select this and let it works. Sorry, I'm over the time. So I'm going back to here. What I'm going to do is I'm going to, after creating the fishnet, I'm going to start analytics tools, go down to close this up again, go down to spatial analysis tools, click on extraction, and I'm going to click on extract value to point. Now when I click this, it comes here. Click on the fishnet that I selected, come up here, click on them. Based on what Collins have explained, I'm going to check this one, interpolate value by point, and I'm going to check append all raster input attribute to this. So this is option, but it's necessary I check it. When I finish, I'll run the code, and when I run it, it's going to add the value to me, which is the raster value. So it is going to extract the raster value to this. Anytime you check and you didn't see good, you are seeing this warning, meaning there is problem. What is the problem here? The problem is that it added some and it didn't add some. Now in my case, what I'm going to do is I'm going to click here and I'm going to right click on it and I will say sort ascendingly. You see the ones that are not having value are the ones that are falling outside this. So if I select all of them like this, let me select the first one here and go down to the end of it, the beginning, holding shift and select one. If I close up this, you see that the ones you selected are the ones that are not touching this. You can see it's not touching the them. You see, that's why it is not selected. Now I can make this selection, open attribute information here. As you can see, these are the ones that does not have value attached to it. Then I can switch selection by clicking here, and once I click switch selection, I can close up this, go to selection of that point and say selection and say copy record for the selected. I'll go down here, click on this, and then I'll paste it, and then I can submit it to my boss. This is the point, but something is also remaining. The something is remaining is what we did. I'm going to last time, I'm going to this active box again. I'm going to data management tools, and I'm going to feature here, and I'm going to say add XY coordinates. It will pick it from the coordinate system I'm using. So I'm going to still use this extracted here. So I'll drag it and put here and click OK. And that is going to run and add XYZ value for me, and it has been added, and that's good. So I'll open up here and you see that I have XYZ. The same thing, you can see those ones here. I'll close it up again and right click on the layer of extraction, go to selection, go to copy record, go back here, click on the beginning and still paste it. Now village people didn't work, so extraction, no, I'm supposed to go to selected, go to open up this. Now this is the selected one, so close this, open. What I did was I created a new layer for the selection instead of copy record. So I'm going back to there, go to selection again and go to copy record for the selected feature, and go back to Excel here and click on the beginning and paste it. And I have this coordinate here. Remember, I can copy this and say cut and go down here and say paste and click on this and delete it, then click on this, delete it, then click on this, write it easting, go to this, write it nothing, and go to this and write it height or elevation, and then I will submit this except to my boss and I tell him I'm done. So this is how you achieve it, and this is how it is done. So on this note, we are going to stop here. Remember our goal. I'm sending this away. I'm also sending this away. I'm also sending this away. But I'm going to leave with the contour, and this is the contour. I'm going to turn off the labeling, and this is what I have in labeling. Remember what I said, you will be building a very big infographic for me. So follow what I did very well, and then this is where I'm going to stop right now. And I think we have 4 minutes above our time. And on this note, from me, I'm stop sharing my screen.